Hello again, everyone. We've gone over a lot of topics on mathematical operations and evaluating expressions, so now it's time to start thinking about equations. Equations are made up of some expressions on both sides of an equal sign, similar to this expression here. They can have any combination of numbers and variables, and it's the equal to sign that's the key component of an equation. And as you would expect, it's what makes the left side of an equation equal to the right side. Today, we'll be discussing how we are able to manipulate such equations. We are allowed to do almost anything we want to an equation. Add to it, subtract from it, multiply it, divide it, raise it to some power, pretty much anything we want to do. However, in order for an equation to remain true, whatever operation we do to one side, we must do to the other side as well. To demonstrate this, consider an obviously true equation, 8 equals 8. If I suddenly decided I wanted to add 2 to only the right side of this equation, I end up getting the 8 on the left is equal to 8 plus 2 on the right, and doing the addition will give 8 equals 10. And this doesn't make any sense. 8 is not equal to 10. However, if I wanted to add 2 and did it to both sides of the equation, the left becomes 8 plus 2, the right becomes 8 plus 2, and doing the addition, I get 10 is equal to 10. And this equation is true. So you can see if I add anything to one side of an equation, I must add it to the other side as well in order for it to remain true. Let's try this with subtraction now, and subtract 1 from each side. If I do 10 minus 1 on the left, I get 9, and 10 minus 1 on the right is also 9, so this is still true. Now what if I wanted to multiply both sides by, let's say, 3? On the left, I get 9 times 3, which is 27. On the right, 9 times 3 again, which is still 27. I still get a true equation. How about dividing by 9 now? Well, if I do that, the left is 27 divided by 9. 9 fits into 27 3 times. And I get the same thing on the right. 27 over 9 is 3. This is still true. Let's take this equation, 3 equals 3, and say I wanted to square both sides. 3 squared on the left is 9. 3 squared on the right is also 9. As you can see, no matter what operation we choose, as long as we do it to both sides, the equation still holds true. It's pretty clear how that example worked with the same number on both sides, but now how about we consider something with a variable? Let's consider the equation x equals 2 and try doing some operations on this. First, let's try adding 5, and we want to do it to both sides. On the right side, we get 2 plus 5, which is just going to be 7. But on the left side, x plus 5, we can't combine those terms, so we have to just leave it x plus 5. Next, let's do some multiplication. We'll multiply both sides by 2. On the right side, it's simple enough. 7 times 2, we get 14. But on the left side, we have to realize that we're multiplying the entire side by 2, not just one single term. To help us make note of this, it's useful to put the entire side in parentheses when you're doing the multiplication. So we see from this that the 2 is now going to multiply the x plus 5 inside a set of parentheses. Now, what if we wanted to square both sides? What would be a good way to write that? Well, on the right, it's easy enough. It's just one number, so that's all that gets squared. However, the left side, we're going to have to square everything. So again, it will be useful if we just put everything in another set of parentheses, or brackets in this case, and that's what we will be squaring. We are squaring the entire left side. and that's going to be equal to the right squared. 14 squared gives us 196. Lastly, let's do some subtraction. We'll do minus 6, remembering that we have to do it to both sides. On the left, we are subtracting 6 from what is already there, so we'll just get that same expression, now minus 6. And on the right, we have 106 minus 6, which will just give us 190. The main point to get across here is that for addition and subtraction, you simply tack them on to the expression you had beforehand. But for multiplication, division, exponents, and even radicals, it's best to put the entire side you are operating on inside a set of parentheses. This way you know you're acting on that whole side. Now that we've gotten a bit used to operating on both sides of an equation, we can start thinking about what the best operation to use would be in some cases. Let's consider this equation, and suppose we wanted to get the y by itself. Right now the y is being multiplied by 4, and then has a 2 being subtracted from it. To get a variable by itself, we generally want to cancel the operations in the reverse order we would do them in our order of operations. Since the minus 2 is the last operation being done to the y, we will cancel that first. To cancel an operation, we use the inverse of that operation. The inverse of subtraction in this case will be addition. We will add 2 to cancel the minus 2. And remember, we must do that to both sides. On the left, there's no constant terms for this 2 to combine with, so we simply get x squared plus 3x plus 2. Meanwhile, on the right side, the minus 2 and plus 2 combine together to just give 0. They have canceled each other out, leaving just the 4y. Another way this tends to be worded is that we have moved the 2 to the other side. And you can see whenever we move a term to the other side like this, it switches sign. We have now gotten rid of all the constant terms on the right side. We can just ignore this plus 0, leaving only a 4y. The 4 is multiplying the y, so to cancel it, we do the inverse operation of multiplication, which is division. We will divide by 4, and we must do that to both sides. Remember, with multiplication or division in this case, we want to make sure we're dividing the entire side by that 4, so we will put the side in parentheses. This helps us see that we will be dividing the entire left side by that 4, and on the right side, we get 4y divided by 4, and we can cancel these 4's. 4 divided by 4 will just leave a 1 times that y. So for our final result, we just get that left side is equal to y. We have gotten the y by itself equal to all of this on the left side. Getting variables by themselves will be an important aspect of working with equations moving forward, and it will be crucial to know what operation to take. While there will be a learning curve which order to go in, for now, just recognize that to cancel an operation, we want to use the inverse operation. To cancel addition, we'll use subtraction, and vice versa. To cancel multiplication, we will be using division, and also vice versa. Then, exponents and radicals are also inverse operations. Now that we've been introduced to manipulating equations, next time we'll be using these principles to solve linear equations. Until then.